Yes, welcome back. So in previous class we have seen about the different blocks of the FPGA. We listed out actually, and up to CLB we have seen. So what is the function of IOV block, CLB block, and again in the CLB there are different sub blocks. Okay, and mainly LUT structure. How the different logic circuits can be realized with different sizes. With different sizes, you can realize in the LUTs like that. And then coming to another section in the CLB is slices. Okay, so what is a slice is? Slices we can treat as the group of LUTs, flip-flops, and multiplexers are considered as the slice. Okay, so in each is in CLB in general, how many such slices will be there means um, around two many slices are there. I mean, in based on the FPGA, suppose if you take Artrix 7XC 7A35T has 5200 slices it consists. 5200 slices. Out of these 5200 slices, 3600 are the slice L and 1600 are the slice M. Okay, so both the slices are used to realize the combinational logic functions, but especially slice M are used to distributed memory it is used as a distributed memory element. Then what are the I mean how many LUTs, flip-flops, multiplexers each slice can consist means for 6 input LUTs in each slice you can observe 6 input LUTs, 8 flip-flops and multiplexer. Okay, so like that we can have the knowledge about the slice. Then coming to another block is block RAM. Already well known, RAM is a random access memory element. Random access memory RAM expansion for the RAM is random access memory used to store the data. Okay, how it will store the data means it stores one block of 36 kilobits or two blocks of the 18 kilobits data. Okay, one block of 36 kilobit data or two blocks of 18 kilobits data. Okay, so and in FPGAs we have 50 such blocks, so that the capacity of ROM block is 1800. We can consider 1800 kilobits. Okay, so totally the RAM block is for the storing the data. Then coming to another block called DSP slices. The purpose of these slices is to do arithmetic and logical operations. Various arithmetic and logical operations. We have the DSP slices. 90 such slices, DSP slices we have in the RTX 7XC 7A35T. Okay, and coming to another thing, that is the clock management block. So actually there is no internal clock generating system. The clock is collected from the specified inputs into the FPGA. Okay, so in order to maintain a synchronous operation between various blocks of FPGA, the FPGA definitely needs the clock information, clock signal. Okay, and properly the clock is managed between various blocks of the FPGA. Okay, and another block is ADC. XADC means analog to digital converter block. So that is the FPGA, after collecting the analog data, it is converted into digital form. That is, by applying the sampling and quantization techniques, the received analog data or analog information is converted into the digital information in order to process the data in the FPGA. Okay, FPGA is a digital device. Okay, it processes only the digital information but not the analog. Okay, so to convert the analog into digital, this block is particularly helpful. And here in each XADC we have two ADC modules. each module can acquire 1 million samples per second. Okay, can handle 1 million samples per second, and each sample can be represented by a 12-bit. So therefore the range we can represent it as 0 to 2 power 12 minus 1. Okay, so like that you can take the information of XCADC. And another block is high speed serial input output transceiver. High speed serial input output transceiver. Okay, already you know transceiver means it transfers the data in both the directions, and the speed of such a transceiver is in terms of gigabits per second. So whatever the FPGAs in the base system has, that maintains speed at 3.75 gigabits per second, but in RT boards there is no such arrangement. Okay, and coming to another block, that is peripheral component interconnect express. So this is the unit used to provide the serial interface between FPGA to peripheral components. And there is another thing is interconnect resources. It includes the wires and programmable switches. The purpose of these are to provide the connection between different blocks located in the FPGA. Okay, so the interconnecting resources includes just wires and programmable switches. They provide a joint between various blocks existed in the FPGA. Okay, so like that you can take the different blocks of FPGA and their functionality. Okay, then coming to that is FPGA digital system design philosophy means, so the points you need to remember while using the FPGA. Okay, that is, so the FPGA, the point which is you are going to remember is that is free to choose the design methodology. In other words, the same digital system design can be implemented in more than one way. And another thing is, there is no predefined block. in the FPGA in order to realize. Okay, so the designer has a powerful and unconstrained resource to construct required design blocks, and it allows the HDL programming and reconfigurable capacity the FPGA has. So these points the designer has to be remembered, so while using the FPGA. And what are the advantages and disadvantages of this FPGA means compared to other way of realizations like ASIC realization, microcontroller realization, and discrete component realization. The FPGA has a fixed size. It doesn't dependent on the logic circuit which you are going to implement. Okay, and internally it has the interconnecting wires and programming switches, so that there is no issues in the interconnecting wires. Okay, and it allows the user allows the reconfigurable action by the FPGA allows the reconfigurability. Okay, so whenever the necessity, the designer can easily change the data which the logic circuit which realized by the FPGA. Okay, that too, the FPGA, in case of FPGA, not the serial way of implementation, parallelly you can realize here, so that the HDL languages are available. So simultaneous programming capability here you can observe, but not like C. In case of C type of programs, so the sequential statements you can write. Okay. So that is the specialty, but only disadvantage is the designer has to know the HDL languages and their writing skills. Okay, so that is the advantage and disadvantage. And FPGAs are used in many areas like automotive, aerospace, broadcasting, military, defense, in the industrial applications, medical applications, where communications purpose. In almost all the areas we can use the FPGAs. Okay. Uh, so now I am going to end this session. In the next session, we can see about the VHDL fundamentals. Okay. Thank you.